We here at NO believe it is our duty to inform you, the citizens, about the new source of power generation, nuclear fission power. Now you might be thinking to yourself, how did this miraculous invention make its way into today's society? Well, I'll be happy to show you. In 1902, Ernest Rutherford showed that radioactivity, as a spontaneous event emitting an alpha or beta particle from the nucleus, created a different element. Fission, the basis of the atomic bomb, was discovered in Nazi Germany less than a year before the beginning of the Second World War. It was December 1938 when the radiochemist Otto Hahn and Fritz Strassmann, while bombarding elements with neutrons in the Berlin laboratory, who made this discovery. Otto and Fritz went on to make several more contributions to the understanding of nuclear fission. And then, in 1942, Enrico Fermi, an Italian/American inventor, designed the world's first nuclear reactor underneath the University of Chicago's football field. Enrico also had a major role in the creation of the atomic bomb. Now, of course, there were many key scientists that aided in the discovery of nuclear fission. A few most notable mentions are a German chemist that in 1789 discovered uranium, Henri Becquerel, a French physicist that discovered radiation in 1896, and Niels Bohr, a Danish physicist that changed how we saw electrons around an atom. There are many, many others who were vital to this process, but we would be here all day if I listed them all. Alrighty, Mr. Spokesperson, you might be thinking, this is great and all, but how does this invention work? I'm glad you asked. Nuclear fission and nuclear fission reactors, more specifically, use the heat generated by a nuclear fission process to drive a steam turbine, which generates usable electricity. How does this reaction take place? Well, steel rods containing uranium-235 or uranium-238 are placed in water. Thermal neutrons are capable of producing fission reactions with the uranium. During this reaction, more neutrons are given out, activating more fission, causing a chain reaction. The heat that is created from this fission is pumped into another chamber of water, where the water becomes superheated and then becomes steam. This steam is run through a turbine connected to a generator, creating electricity. The large cooling towers can be seen on reactors are just that, cooling towers. This is where the extremely hot water is stored to cool off. Now that we have the basics down, let's dive into the benefits and negative effects of this method of power generation. As for the negative effects, nuclear fission power gives way for more nuclear weaponry. Nuclear waste and pollution also poses a problem. Spent nuclear fuel is radioactive and contains very poisonous chemical elements. Accidents and disasters such as Chernobyl and 3 Mile Island have had devastating effects on the environment. As for the reasons nuclear energy is helpful to us, nuclear energy reduces the emission of carbon dioxide. By using nuclear energy and not other means of fossil fuel power generation, since 1976, about 64 gigatons of greenhouse gas emissions have not been pumped into the atmosphere because of nuclear energy. Nuclear energy is much more efficient than any other form of power generation. 0.1 ounces, 6 grams of nuclear fuel, can yield the amount of energy equivalent to that generated by a metric ton of coal, which makes it much more efficient. Thank you for joining us today. We here at NL believe nuclear energy is the way of the future. With lower emissions and increasing amounts of research being dedicated to refinement and efficiency, nuclear energy might prove a solution, even if not a permanent one, to the world's energy crisis. Well, that was a lot of information. And lucky you, we have even more to tell you. In a nuclear reactor, beta decay occurs because the common feature of the fission product is an excess of neutrons. The equation for this decay is uranium-235 has 92 protons and 143 neutrons, while uranium-238 has 92 protons and 146 neutrons.